Good morning, everyone. My name is Venkatnagsai Raju Allari, and I'll be doing a presentation on the orifice meter. So let us get into the outline, where we will be looking into the contents, which includes the introduction, construction, working principle, advantages, disadvantages, and finally applications. So let us start off with the introduction, where an orifice meter is simply a type of flow meter used to measure the rate of flow of liquid in a form of stream using the differential pressure measurement principle. It is used for robust applications as it is known for durability and is, of course, economical. It consists of an orifice plate, which is the basic element of the instrument. A differential pressure drop is developed across the plate, which is linear and is in direct proportion to the flow rate of the liquid. So now let us look at the construction. You can see the diagrammatic representation on the right, where we have four main components or parts to look into or are of interest, and those include the inlet suction, the orifice plate, flow conditioner, and finally the outlet section. So let us gain some insight, brief insight into all these four parts. So first we have the inlet section, which means the fluid will enter into the orifice meter through this place, this part here. And in the case of orifice plate, it is situated between the inlet and the outlet, and the plate is used to generate pressure drop that will enable the flow rate. The orifice plate construction, which is essentially having thin size, having one hole from that where you'll have the water be passing. Now let us go to the flow conditioner, where the flow conditioner is used to increase the linear flow in the inlet section of the meter tube. This flow conditioner is installed nearly uh, to the inlet section of the meter tube. Finally, you have the outlet section, where the pressure of the fluid is being discharged and determined. So let us get into the working principle. Again, you have on the right a representation of what is about to be explained. So please look at that while the explanation is being given for a better understanding. As the fluid approaches the orifice, the pressure increases slightly and then drops suddenly as the orifice is passed. It continues to drop until the vena contracta is reached and then gradually increases until approximately 5 to 8 diameters downstream. A maximum pressure point is reached that will be lower in the orifice, that is upstream. Here you have an equation to check to support the above principle. So let us get into the advantages. So we can, though there are many, let us take four to promulgate this point. It is cost effective and quite easy to use. It occupies less space, making it ideal for space constrained applications. It can also be used to determine flow rates in large pipes. It can be installed in the horizontal or vertical positions. Disadvantages: it requires homogeneous fluid, requires single phase liquid, requires the flow of axial velocity vectors. It causes a pressure drop in the fluid. Its accuracy is affected by the density, pressure, and viscosity of the fluid. The range of measurement of viscosity is limited of fluids. It requires straight conduits to ensure accuracy is maintained. The pipe must be totally special for the measurement of the flow of liquids. They have low range capacity. Finally, you have the applications, which involve the use for measuring the flow rate of fluids in their single state, water treatment plants, petrochemical plants, natural gas industries, refineries, as well as to measure the flow rate of fluids in a mixed state. which is observed in the case of wet steam or natural gas with water. Thank you.